Okay, so we're going to talk about blood flow and blood pressure. And because I already created this video, this is a video that just is me going to talk over the notes. Okay, so blood flow can be measured in milliliters per minute, while as blood pressure can be measured in millimeters, actually milliliters per minute, and blood pressure is in millimeters per mercury. So remember that we did talk about atmospheric pressure and the importance of that, those partial pressures in the respiratory system. So this is also important in blood pressure. When we talk about the heart's ability to pump the blood and how much blood it pumps out per minute, we're talking about what is called the cardiac output. This cardiac output can actually change depending upon the requirements of the body. So, for example, when you're exercising, your heart rate is going to go up and your stroke volume is also going to go up. And those two things are going to increase your cardiac output. So, this is defined as the amount of blood pumped by each ventricle in every minute, is the cardiac output. So, we could calculate this looking at rest. We could say that the cardiac output is 75 beats per minute. That's the heart rate. And then this is the stroke volume. So stroke volume depends upon a variety of things like the amount of blood that is coming back to the heart, as well as how forcefully the heart contracts. And so this is about, if we measured it in milliliters versus liters, this is about 5.25 liters per minute. That's a lot of blood that you are pumping out to your body every minute. That is almost the entire amount of blood that you have in your body. That's approximately how much blood people have in their bodies. So when we look at blood pressure, we can talk about the ability of the blood to flow through the blood vessels. And this flow of blood is always from a higher to a lower pressure. Hence, we have the difference in the pressures. So when you pump the blood out through the arteries, that is under high pressure. And then as it moves through the circulatory system, it's going to start to lose pressure. But it's always going from a higher to a lower pressure. So there are a variety of things that can affect the flow of the blood. We're going to talk about resistance here. So that is the resistance to flow. So this is very much like a physics problem when you're looking at the movement of fluids through a pipe or through a hose, for example. So some of the things that affect the resistance is your blood viscosity. So that means how thick your blood is. And that is most directly related to the amount of erythrocytes, the amount of red blood cells that you have in your blood. This increases the resistance here, and that decreases flow. So if your blood is too viscous, then you're going to have a problem with flow. Remember that we did talk about how sometimes athletes do hormones like EPO, which increases their erythrocytes, which could cause a problem there. This second one is actually really super important because it is the way that our body allows for the shunting of the blood to different areas. So we can talk about vasodilation, where the blood vessels get larger in diameter. And you'll remember that the blood vessels, specifically like the arteries, are very muscular and they have lots of smooth muscle. And that smooth muscle actually has two layers, which allows it to either constrict or to dilate. So as we increase in the diameter, we're going to decrease in the resistance. And that, if we look back up at this, right, at this formula, that is going to increase your flow. This is as opposed to vasoconstriction, where we decrease the diameter, we increase the resistance there. This would be like putting your thumb over the end of a hose, and that is going to decrease flow in that particular area. So blood always travels in the path of least resistance. And so by constricting and dilating your blood vessels, you can shunt blood to different areas. The best example of this is in your skin, where you could shunt blood to the capillaries in the skin when you're hot to get rid of excess heat. And then those capillaries are going to constrict when you're cold to shunt blood away from the skin, so you do not lose heat, that you actually retain heat. Okay, there's one more thing that affects resistance, and that is your blood vessel length. So as you increase the length, you increase the resistance, and then you decrease the flow. One way that we increase length is by becoming bigger. So children actually have less resistance in their blood vessels because they're smaller. And then as we grow older, we get more resistance because our blood vessels become longer. And then if we are very big, like for example, overweight or have obesity, then that is going to cause a problem. And this problem is going to make your heart have to work harder at pumping the blood. And so what this means is that this heart is going to perhaps get damaged from having to work so hard. And where you have blood vessels that are close to the heart, you might have high blood pressure there because you're having to force the blood through such a long network of vessels. And so this becomes a big problem with cardiovascular health in people that are overweight.